Hi, John Dignan here. I want to introduce you to the CT1000 cable testing system and the CT1000K, which is the complete cable system for Kinsey planters and other devices. Real proud to show you the CT1000 today. We're wrapping up production, or still rapidly getting units out of here. But anyway, the CT1000, as you receive it, comes in its own Pelican case. And when you open up the case, the tester itself is there. We'll want to give you a quick run through with this, but the other items in the package include a harnessing kit and terminator kit. So as we talk here, we'll get a better handle on how this all goes together. The CT1000 is the cable testing system. This particular one is a 24-wire tester, and there will also be available 12 and 6 and other units in handheld versions. And the tester itself is designed to look for conditions, what we're calling opens or short conditions, on all types of cable harnessing that's developed with specific harnessing going from a manufacturer's cables to the tester itself. So again, this tester is able to deal with 24-wire cables as a maximum. And the as an overview, when you look at the unit, the power switch is down in the lower part of the screen. When I flip the power on, this unit is really ready to ship. When I turn the power on, you'll see the LEDs for the battery status indicator lighting up, and we've calibrated it basically based on the voltage that is available from the sealed lead acid onboard battery system. So our battery status is there. Anytime we're at 11 or above, we're in good shape. When we get down to 10, you're going to start finding that the tester itself will fail. So anytime in here, the charger can be used. The input connectors are right next to the battery status indicator. There's two connectors marked J1 and J2. J1 is a 37-pin amp connector. J2 is a 16-pin amp connector. Just above that, so these are our input connectors. Just above that is our sounder or audible alarm, and an on-off switch above that for the sounder functionality. So if you're doing in-depth troubleshooting and you don't want to listen to the beeper anymore, want to use the lights, you can kill the sounder. Directly above that is the input for the charging jack. I've got a charger available, so let me go ahead and plug this in. And when I plug the charger in, you see the battery voltage immediately came up on our battery status indicator. And it's worth mentioning at this point, the tester can be used while the battery's being charged. So if you're in a real lengthy troubleshooting process, you know, that can save you there. And then as we look back on overview again, the 24 wires associated with the cables that we're testing are turned on and off for testing status using these banks of 12 switches at the top of the CT1000. And there's two rows of switches associated with wires 1 through wire 12, and then in the second bank, wires 13 through 24. Then again, as an overview, down below that is the status of those wires. Now, we turned our unit on. We don't have any input connectors, so basically there's no activity, no error conditions on any of the wires, and that's really because we don't have any of the wires activated. So this is our LED status. These green LEDs to the left indicate that on that group of 12 there is no error. And then to the upper left from there is the alarm indicators for each group of 12, along with the alarm reset. So the other function on the tester we haven't talked at all about are these switches, and these allow you to select the number of terminators, which will make more sense as you become familiar with the operation of the system. But 3 wires can have multiple termination points hooked to them. So let's just go ahead and look at things. On the upper bank of switches, the top row of 12 says switch up to test, switch down for no test. Right now they're all in the no test condition. So down below, same situation. So I'm going to go ahead and tell all these things, yeah, I do want to make a test. So I turn on 1. A couple of things happen. I turned on 1. The red light, or my green light for all okay, disappeared, and it now shows an open condition, and we've got an alarm. And I can't reset the alarm until the problem goes away. So if I turn wire number 1 off, our OK ready light comes on. I had the sounder shut off. So let's start all over again from the basic condition. If I have an error on, let's say, wire number 5, light number 5 shows up, our all OK indicator goes out, and our alarm LED comes on. Wire 5 is shown as an open circuit since there's no connection. Now I can turn off the sounder by using the sounder on off switch. So now we can continue to test without having to listen to the sounder. So a quick test for the unit, if I turn on all of the wires associated with all 24 rows, you're going to see that all 24 rows, or all 24 wires are showing as open. And it would totally make sense that both groups are open because there's no connector plugged in, there's nothing hooked to it. So we have an alarm condition, and we can't reset it until all these issues go away. So go ahead and kill it real quick. Now, once we've done that, our all OK light come back on. Now we can reset each group. So when we're working with specific wires and isolating problems in harnessing, there's times where we want to short the adjacent wires. So we're able to do that. Again, I'm going to go ahead and turn them all on. And then you'll see the point of the switches below. If we wanted to see whether wires 5, 6, or 7 are shorted to any other wires, then we can go ahead and basically short all of these. So now I have a short condition. All the other wires are now shorted back to common or ground, except the 3 that we're interested in testing. So we can go along then and gently move the wire until we see an issue come up that is going to take us through the diagnostic process. Put them all back in the no short condition, and then shut them all down, and reset. That's a real quick overview. Now, the terminal out here is used for a chassis ground. Let me just show you real quick. Again, as we look at the testing process, one of the things I'm able to do is actually check all of these input wires to show you how it corresponds. I've got a jumper wire laying here someplace. Go ahead and stop it. Okay, we're back. We found the cable there, and I may not bother editing that, so sorry about that. So each of these connectors, they're numbered 1 through 37, and you can look closely inside. But when we tell the system that we want to test all of these, and I'm going to go ahead and kill the sounder. Now, right now, all of these wires are opens. So if I take a jumper wire and go from the common or chassis ground, and I go ahead and touch wire number 1 or pin number 1, you'll see LED 1 shows up as a short. If I go to 2, 2 shows up. 3, 4, 5, 6, 7. So what happens, you can go all the way through the list, or just take your lead and run it across, and you'll see the LED sequence as you move it through. So you can do that with both testers, but that kind of gives you a feel for how the thing's wired. And then once we're comfortable with that, the inputs match up with specific numbers 1 through 24, 1 through 16 here. Now, in order to, let's go ahead back out. In order to make the tester function properly, you've got to have an interface cable or kit to allow you to perform the test. Now, on these initial units that are shipping to Kinsey dealers, the kit comes with a plastic bag that includes a adapter harness and some devices that we'll talk about here. They're called terminators. But what that kit does is allow us to check specific things. Now, let me show you the basic harnessing I've got pulled out of the bag now, and let's go ahead and take a look at that. Now, this harnessing comes from the kits that, or the interfacing kits that are available from Kinsey today, include a dozen or so cables and terminators, and you'll see that we're using, these are the Kinsey part numbers associated with the individual pieces. So this harness then has that Kinsey part number on it. And then additionally, the opposite end, this particular harness will in fact hook to all of these different associated Kinsey cables. So we pick a cable then, or pick our harnessing based on what it is we're trying to accomplish. Now, the kit that comes with it is specific to the row module connector for cable. It's cable number A19408, and I have a 19408 here that's off the planter, obviously, but basically the connection, or the connector or the part numbers associated with the connectors are all available so that you can easily plug them into the piece of equipment. So what we're going to do then is we're going to hook the harness then for that 408 cable. We're going to plug that in using the 16-pin adapter, and then I'm going to take the harness. So if we were on the planter, we would just simply plug in at the row module termination point, and then I pick the cable, the connector that's marked with that cable on it, and then I just insert it. Now, at each location then, out at different points on the planter, you're going to plug in devices called terminators. And what these terminators do is they give us a signal that we're able to know specifically at the tester what we're looking for. So when we plug these guys in then, so we're unplugging the seed module and we're plugging in the terminator. And yeah, we are. There you go. Plugging in the terminator. To release it, you're going to push this button. Then there's two other terminators required. This guy's a 6-pin, and it's going to the MDM. So the part numbers are listed on there along with the associated component. So we're going to plug him in here. Whoop. Seat it. And then we have one other connection that is the LIN connection. So we're going to plug him in here. And we're basically we now have termination points. So when we get the tester then ready to check this thing, we're going to be looking for a couple of things. Or when we set up the tester, first thing to keep in mind before the tester is connected, so before I did this at all, verify that you do have all the terminators used up. We don't want anything else hooked on the out the harness, and some of the harnesses are really quite sophisticated, so make sure there's never any power there. And then beyond that, we're looking at this connection on the this is what will show up in your Kinsey service manuals. So that row module connector, these are the pin numbers associated with it. And then these are the pin numbers associated with the connectors that we have terminators plugged into. So the way we're doing this, we pick one wire number or one pin number that we're calling the common, and then we're making our checks between all of these points. So down at the tester then, when we're actually plugging into the tester, we're really only using 3 wires, tester wires 1, 2, and 3, and then our common is down here on pin 16, which goes to the pin number 2 on the RM connector. Now these other ones, these are the other Kinsey cables that can be plugged into this same GA22376 harness. So keep in mind there's any number of combinations available. So we're basically checking 3 wires. So back at the tester then, when we fire this thing up, we turn the unit back on and we tell it we've got our terminators plugged in. We tell it we want to test row 1, 2, and 3. And we've got the sounder going off, and it basically is saying short circuits. So, you know, how can that be? Well, what's being missed there on the chart, let me kill the sounder. What's being missed is the connections that we're actually checking. When we check out to the MDM, or really any of these, there's multiple pieces hooked to each wire. So on the chart then, when you set up the tester for any of these cable harnesses, what we're looking at is pin number 1 on the tester harness becomes wire number 3, which has 2 terminators. So that's what these switches are used for here. So I dial this one then, it's on terminators 1, I dial it to 2, and now it's no longer showing alarm on wire number 1. So wire number 2 then goes to wire number 4, and it has 2 terminators associated with it. I go to 2, and there goes our error there. Then wire number 3 goes to wire number 1 and has 3 terminators. So 1, 2, 3. So now all okay, reset. So then if I dial up, I'm back in an open circuit. So if I go on, I'm okay. If I go 1 down, I'm shorted, open. That's because we're looking for a certain percentage of error from the target. So that's why it is so important that these be set up. Now, if you're out there in the field and you're operating this thing, you may run into situations where you have intermittent cables. So what you're going to want to do, it says that everything's good, but you've got your terminators all in place. So what you want to do at that point is go along and just kind of move each inch. Make sure the sounder's turned on so you can hear it. Keep moving each inch. And if you start to lose a connection with a in this case the seed sensor, you know, I'm not going to cut the cable up for you, so let's just kind of unplug this and show you what it'll sound like. Basically, as I start to unplug this, I've got error going on. See how I'm kind of intermittently just hooking that up? I've got errors on wires 2. If I pull it off, kill the sounder. I've got, in the case of the seat sensor terminator. When I pull the terminator off, it's basically an open condition on wires number 2 and 3. Okay, when we're doing diagnostics in the field, once we determine which connections we've got an issue with, especially in intermittent situations, the tech support guys at Kinsey may be able to actually talk you through identifying which specific wire is bad and maybe even where it's at in the harness. And from that point, they may direct you to go ahead and perform some kind of a part-time fix to get the device back in the field as soon as possible until the cable can be replaced. Keep in mind that the different harnesses for different pieces of equipment are constantly coming available, and the tester itself, the CT1000, isn't necessarily specific to any manufacturer other than the development of the cable. So potentially this could be used to troubleshoot cable harnesses on all types of machines around your operation. When we get ready to shut things down, power things down, I've got my charger unplugged. You'll see that on a full charge we stay up around 13 for a while. Then it'll sit from 12, perhaps drop down to 11 through a lengthy process of troubleshooting, and then beyond that, don't let the battery go completely dead. You'll find if you do leave it on and close the lid up, you'll find that when it hits just over 10 volts, the sounder goes off and the lights come on, and you that's the warning basically that it has to be charged. So you can't necessarily overcharge these things, but it's necessary that you use the correct charging tool. Hope that was helpful to give you an overview of the product. If you have questions or comments, you can contact me by going to agtester.com and hit the contact us button, and then just shoot me off an email, and I'd love to get back to you. Thanks very much for looking at the CT1000 and 1000K.